Hey everyone, Mr. Skelton here. We're back at it with Unit 2, Lesson 10, and today we are going to press on with the lesson that is challenging, and so it's real important that you pay close attention, and if you need to pause and rewind and rewatch, I would suggest that you do that. I understand too that when you come back into class, you'll probably have some questions, and I'll probably end up reteaching one or more of these concepts that you'll see today. But once you get the hang of these, once you do a few of them, especially in class, I think you'll catch on pretty quick. I'm going to teach you to do these matrices and solving these matrices by hand today and when we come together in class, but I'm also going to break out the old trusty graphing calculator, and you'll find that that will make your life way easier. So bear with me as we go through this and as we go through these problems in class, because they can be a little challenging, but I think at the end of the day it's going to help you grow your math brain a little bit. So here we go. What we're trying to do today is two things. We're going to find the determinant of a matrix, and we're going to find the inverse of a matrix. And the nice thing is you use the determinant to help you find the inverse, and you use the inverse to help you solve. All right, and so I'm going to show you how that's done. So let's just jump right into it. The first slide here says solving matrix equations. Can you solve this matrix equation? If you look at it right there, a lot of you are probably thinking, well, can I divide, because it's multiplied by, this 2 by 2 is multiplied by x, so the opposite of multiply is divide. You can't divide matrices. Remember in last lesson we only multiply matrices together. And so we can't divide. So that's what I put right here. My guess is that at this point the answer is no, but don't worry, before you leave this video, you will. Let's do it. So I'm going to give you some background information and show you some associations to help you transition from what you do know already to what you're going to learn today. So something that's similar to you. Can you solve this equation? Now, we've had some issues with students trying to divide by 2/3 on both sides. I've seen some of you do that. Technically, what we want to do here is we want to multiply by 3/2 on both sides. Now, that is called the inverse. Multiplying by 3/2 is the inverse of 2/3. And when we do that, what do we get? We really get 6/6x equals, right? You can cross divide and you get 18. Well, 3 times 2 is 6, 2 times 3 is 6, and 6/6 is 1. And we get 1 times x, which is 18, and 1 times x is just x, so we get 18. Now, a lot of you know how to do this already, but I want to point out a couple things. This right here, this 3/2, is the multiplicative inverse. It's the inverse of 2/3. This right here, this 1, is the multiplicative identity, okay? And the multiplicative identity just means that when we get 1 times anything, we get anything, which is in this case x, okay? So this is the multiplicative, I'll just put multiplicative identity. This is the multiplicative inverse, okay? And we use the inverse to help us get the identity, which then lets us alone just get x, which is what we want. Now, you normally don't think about all of that when you do this. Most of you know you just times by 3/2 on both sides. You just cross this out, you just are left with x, and you get x equals 18. You usually don't go through and think about what you're doing, but it's really important that you do that because it's going to apply to what we do today with matrices. We'll come back to this slide and make reference to it as we go forward. All right, so the identity matrix. So we just talked about this word identity, right? We used it right here. This is the multiplicative identity, 1 times x, which gives you x. And so what I want you to do here is just think of any 2 by 2 matrix and write it down in your notes. So I'm just going to go 3, 2, -1, and -2. Just making something up. And I want you to multiply it by this matrix. Now remember your multiplication rules. This is a 2 by 2. This is a 2 by 2, right? These two numbers have to be the same, which they are. So our result is going to be what? Our result is going to be a 2 by 2. So that's good. And how do we multiply matrices? We go rows by columns, and we add up the sum. So we go 3 times 1 is 3, times, or plus 2 times 0, which is 0. So we get just 3. If I want to find this element right there, I would go first row, second column. So 3 times 0 is 0, 2 times 1 is 2, 0 plus 2 is 2. Now if I want to find this element right here, I go bottom row or second row times the first column, and I add those together. Negative 1 times 1 is negative 1. Negative 2 times 0 is 0, so negative 1 and 0 make negative 1. And if I want to find that last element in my answer, I go the bottom row times the last column, so negative 1 times 0 is 0. Negative 2 times 1 is negative 2. You add those together, you get negative 2. And what do you notice? You notice that when you took this matrix that you made up and times it by this matrix, which is 1, 0, 0, 1, you are left with what you started with. This right here is what we call the identity matrix. It's just like when we did up here, you're timesing x by 1 to get x. You times this matrix by the identity, and it give you the matrix that you had. Okay? Again, we'll make reference to this. We'll come back to this here in a little bit. All right, let's turn the page over here. So, inverse matrices. So this says, how can you prove that these matrices are inverses of each other? Well, how did we prove that those fractions, remember we had 2/3, right? It was like 2/3 x equals 12. How did we prove that 3 over 2 was the inverse? Well, we proved that when we multiplied them together, we got 6 over 6, which was 1, and that gave us the multiplicative identity of 1, and we just had 1 times x, which just gave us the x. So we knew that 3 over 2 multiplied by 2 over 3, we knew that 3 over 2 was the inverse because it led to the identity of 1. So how would we prove that these matrices are inverses of each other? We're going to multiply them together. And what should we get if we multiply these two together if we're saying that they are inverses of each other? Well, what did we say we were going to get when we multiplied these two together when they were inverses of each other? We would get 1, or the multiplicative identity. So when we multiply these together, we should get the matrix identity, which is what you just saw on this page, which is right here. Let's take a look. Negative 2 times negative 3 is positive 6. Negative 5 and 1 is negative 5, so negative 6 and 5, or excuse me, positive 6 and negative 5 make 1. If I want to find that element right there, it's first row, second column. Negative 2 times negative 5 is positive 10. Negative 5 and 2 is negative 10. Add those together, you get 0. If I want to find this element here, second row, first column, 1 times negative 3. I'm kind of doing this in my head, and maybe I shouldn't because I know some people get confused. So let me go through this very slowly. Second row, first column, 1 times negative 3 is negative 3, and I'm going to add to that 3 times 1, which is 3. What does that give you? It gives you 0, so that's a 0. If I want to find this last element here, that's the second row, last column. 1 times negative 5 is negative 5, and 3 times 2 is 6. Add those together, and you get 1. So what do you know? When you multiply these two together, it gave you the multiplicative inverse. Okay? Now, I want you to always be thinking about the very first slide we started with, which is this right here. So let's just kind of think now what we've accomplished, what we've done. We want to get this x by itself. What are we going to times this matrix by to get the identity matrix so that I have 1, 0, 0, 1 times x, which will just give us x, because 1, 0, 0, 1 is the identity. It's no different than just having 1 times x. So what do we need to do, or what do we need to multiply this by to give us that matrix? We need to find the inverse matrix of this matrix right here. If I can find the inverse matrix of this, times it by this on both sides, because whatever you do to one side you have to do to the other, that will get rid of these two and just leave me with x. and I'll have the inverse matrix of this times this, and that will be my answer. So our goal right now, what we're working towards, is to find the inverse matrix of this 2 by 2. So here's what we're going to do. Here's how you find the inverse. It's a little involved, but we'll go through it slowly and do a couple examples. So the first thing you want to do is you want to start out by finding the determinant. Now I mentioned that in the very beginning. We want to find the determinant. The determinant is a number that allows you to find the inverse matrix. So here's how this works. If you want to find the determinant given a matrix A, B, C, D, this is a specific example here. So say I had 5, 2, 9, 4. This is my matrix, and I want to find the determinant of this matrix right here. Here is what you do. To find the determinant, I'll kind of draw an arrow to it. You simply take A times D and subtract it from B times C. So in other words, you multiply the diagonals together and you subtract them. So you can see here my A value is 5, right? My D value is the 4, so 5 times 4, which is 20. And I'm going to subtract from that B times C, okay? And again, you can go D times A or A times D, B times C, but you always want the AD first, BC is second. So it's always top left to bottom right first, minus the 9 times 2, which is the 18, and I get 2. Now, why is the determinant important? Well, step 2 in this process of finding the inverse matrix is right here. This is like a formula that you're going to have to memorize, okay? So this is what we use to find the inverse matrix of a 2 by 2. Now, I forgot to mention this at the top. We're only going to be dealing with 2 by 2 matrices right now. We can get into some larger matrices later, but for right now, you're going to simply be dealing with 2 by 2s. So you're going to want to commit this to memory right here. So if you want to find the inverse matrix, so again, let's go full circle here. I'm going back to this problem right here. If I want to find the inverse of this matrix right here, 3, 4, 2, 3, if I want to find the inverse of this, this is what you're going to use right here. What you would do is take 1 over the determinant. So we just found the determinant here to be 2. And then what you do is you switch your A and your D. You switch your A and your D. You just put your A value where your D value was and your D value where your A value was, and you negate your C and B. Notice my B value stays as my B value. It's in the same location. I just have a minus sign in front of it, and I negate my C value here, okay? So with this example that we did, this is a specific example, here's how I would find the inverse. I go 1 over the determinant. We found the determinant to be 2, so it's 1 over 2, because that's my determinant. And then you'll notice I switched my A and my D, right? It was 5, 4, but look at here, it's 4, 5. And then I negate my B and C. My B and C were 2 and 9, so now they become -2 and -9. And then what you do is you take this 1/2, which is our scalar, and you multiply it by the 4 to get 2, by the -2 to get -1. 2 times -9 is -4.5, and 1/2 times 5 is 2.5. And this right here is the inverse of this matrix right there. Okay? All right, let's put it into practice here. So this is the question that we had on the very front page. I believe it's the same question. Yep. So now we're back to where we started. Can we solve this matrix? So what's our plan? You should always have a plan. My plan is this. I got to find the inverse matrix of 3, 4, 2, 3. Because if I find the inverse matrix of this, I will multiply it, the inverse times this, and when you take the inverse times the original, what are you going to get? You should get 1, 0, 0, 1 times x, which will just yield what? That'll just give us x, which is what we want. We want to solve for x, okay? In other words, the inverse of this matrix times this one will cancel it out, and you'll just be left with x. So, and then whatever we do on this side, we would have to do on this side as well, and I'll get to that here in a second. So let's focus on finding the inverse. So how do we find the inverse? Well, the first thing we have to do is find the determinant. So what's the determinant? Well, if you need help, go back to your notes. What's the determinant? I take my A times my D, and I minus B times C. So 9, this would be 3 times 3, which is 9. And I'm going to subtract from that 4 times 2, which is 8. So my determinant is 1. Now that doesn't always work out that way. This is a nice situation where your determinant is 1, but that's a good thing. The next thing, so step 3, is I want to find my inverse matrix. Remember, it's 1 over the determinant, so 1 over 1 times, now what do? Remember, I switch my A and my B. Now this works out nice, because, or my A and my D, because they're the same. And then I negate my B and my C. Okay? And then I take my scalar, which is out in front, and I multiply it by all of them. Well, in this case, what's 1 over 1? It's just 1. So 1 times 3 is 3, 1 times negative 4, etc., etc. So I'm going to do this in black pen here. Actually, I'll do it in pencil since I have my pencil right here. So here's how this is going to work. 3, negative 4, negative 2, and 3 times my original matrix, 3, 4, 2, and 3 equals x. Now, I'm going to highlight this one, okay? That matrix, when you solve these by hand, notice it's to the left of the original. If it's to the left of the original, there is order in terms of how you multiply your inverse by the other side. It also has to be on the left side when you multiply it by the 32, oops, I almost made it a fraction, 32, 23. Okay? And a lot of students will miss this and miss this step, and they'll screw this up when they go to solve. Okay? If you multiply these two together, right, 3 times 3 is 9, negative 4 and 2 is negative 8, so you get 1. Negative, or if I want to find this element here, first row, second column, 3 times 4 is 12, negative 4 and 3 is negative 12, that gives me 0. If I want to find this element here, negative 2 and 3 is 6, negative 3 and 2 is 6, that gives me 0. And this column here, negative 8 and 9 gives me 1 times x. So when I multiply these two together here, I got my identity matrix. So really I just have x equals now, because this times x is just x. And now I need to multiply this. Now let's just double check that we can do it, right? This is a 2 by 2. What is this? This is a 2 by 1, because there's just one column. So my 2's are good, so my answer is just going to be a 2 by 1. So how do we do that? We do it the same way we did the other ones. 3 times, I better get my calculator out here. So I have 3 times 32. 3 times 32, which is 96. I'm going to add to that 4 times negative 4 times 23. Negative 4 times 23. That equals negative 92. Add those two together, and I just get positive 4. And then if I want to find this bottom element here, I take my second row times my first column. So negative 2 times 32 is a negative 64. You can do that one in your head. And 23 times 3 is going to give you 69. And 69 minus 64 would just give you 5. So after it's all said and done, our answer for x is a 2 by 1 matrix of 4, 5. Okay? All right. Again, I'll probably do at least one of those, if not more, in class, because I know this is a difficult concept. And then you're really going to get mad at me because I can show you how to do this in your calculator in like 2 seconds. All right? So what I want you to do next is this last slide. I'm going to ask that you kind of try it on your own, but and I even labeled it, here's some practice for you. So on 1, 2, and 3, I want you to just find the determinant. All right? I want you to practice the determinant. Now, if you need to look back and remember what the determinant is or how to find it, go ahead. You know, it should be right here. All right? There's your determinant. A times D minus B times C, and that's all I want. So I'll do number 1 for you. 4 times 3, 12. 6 times 2, 12. What do you do with those? You subtract them. You get a determinant of 0. All right, we'll talk about what that means later, but not in this lesson. Go ahead and hit pause. Try 2 and 3. All right, 8 times 3, 24. 24 minus 14 should just be 10, so our determinant would just be 10 there. That's all I'm asking you to do is just find the determinant. This one looks crazy, right? D times 3 is negative 3D. Subtract from that the quantity of 3 times 3 minus d. Well, what is that? That's going to be, right, if I take, and I'm subtracting this is going to be 9 minus 3d, so that's got to be 9 minus 3d. Distribute the negative through, so that becomes negative 3d minus 9 plus 3d. What happens to your 3d's? They cancel out, and you're just left with negative 9. So negative 9 would be your determinant there. These may take you a little bit more time, but again, go ahead and hit pause. What am I asking you to do? I'm asking you to find the inverse. Now remember, the inverse is a two-step process that involves finding the determinant first and then switching your A's and D's and negating your B's and C's. So go ahead and hit pause and try those and then check your answer. Okay, so the first thing we have to do is we have to find the determinant of each. So that's going to be 2 times negative 4, which is 8, minus 5 times 2 is 10. 8 minus 10 is a negative 2, so my determinant is negative 2. Now to find the inverse, remember it's that formula. It's 1 over the determinant, which we just found to be negative 2. And then what do I need to do? I need to switch my A and my D, so negative 4 and negative 2 switch places, right here and here. And then I negate my B and I negate my C. And then I need to multiply my scalar through. So the inverse becomes negative 1/2 times negative 4, which is positive 2. Negative 1/2 times negative 2 becomes positive 1. Negative 1/2 times 5 becomes a positive 5/2. And negative 1/2 times negative 2 becomes 1. And that's a 2 by 2. So my inverse matrix, or the answer to that one, is right there. Okay. On number 5, again, what's the first thing when finding the inverse? We got to find the determinant. So the determinant is going to be 2 times 3, which is 6. Subtract 4 times 1, which is 4. So my determinant is positive 2. So to find the inverse, it's 1 over the determinant, which is 2. I just found that to be 2. And then I need to switch my A and my D. So 3 and 2 switch. I negate the 4 and I negate the 1 and I multiply the 1/2 through. That becomes now 3/2, negative 2. Let's see, negative 1/2, and positive 1. And there's my inverse there. Okay? I know it's a little bit long of a little bit lengthy of a video, but I wanted to make sure I covered it in full detail. And again, you may have some questions, and that's totally fine. I expect that. I just need to make sure that you ask some questions and help me help you to clarify what you missed from the video. And I'd be more than happy to show you as many examples as it takes so that you feel good about this stuff, okay? All right, we'll see you in class. Take care.